Okay. Okay. So yesterday we discussed about the database buffer cache in pretty much detail, right? We discussed how exactly the blocks are brought into the database buffer cache, right? We discussed about what are the different types of blocks or buffers present in the buffer cache. So we saw something called as unused buffers, which are completely empty, right? Then we saw something called as clean buffers, which have got some or the other data present in it, but it can be wiped off, okay, as part of the LRU algorithm. So whenever the Oracle database server or the server process needs to bring in some new data into the database buffer cache, it will first try to find something called as the unused buffers in the database buffer cache. If it finds any of those unused buffers which are currently empty, okay, it will make use of those unused buffers. If it doesn't find any of those unused buffers, what it will have to do, it will have to apply the least recently used algorithm, wherein what it will do, it will clean up some of these buffers which has the result set or which has the data which was used for some previous queries. Okay, so it will clean up these clean buffers, okay, to make space for some or the other new queries that has been fired by the users in the database. That was the difference between unused buffers and clean buffers. Clean buffers have got some or the other data present in it, but it can be wiped off as part of the LRU algorithm, whereas unused buffers are completely empty buffers. Okay, they can straight away be used by the server process for copying data from the data files into the buffer cache. The next type of buffers we saw was dirty buffers. Okay, we will discuss more about the dirty buffers today. So what the dirty buffers were, we took an example like the insert, update, or delete statements, which are also called as the DML statements. Okay, so as part of any DML statements that gets fired by the users in the database, DML statements which stand for data manipulation language. Okay, so if say the user wants to insert some new values into the table T1, the user fires this query and insert statement. Okay, and he starts inserting rows into the table. Now, all those rows or all those new data will first be placed inside the database buffer cache. Okay, they will be first placed inside the database buffer cache. And the blocks which are going to hold that new data, okay, the blocks that are going to hold that new data which is going to be put into the database, those blocks are called as the dirty buffers. Clear with that much information, Azaz and Mahesh?
Yes, yes, yes.
Okay, yeah, fine. So continuing with that same example, okay, let's say that the user fires this query, create table T2 ID number and okay, and the user says table space employees. Okay. So in this statement, the user is trying to create a new table, or in terms of Oracle, if we have to address it, the user is trying to create a new segment. The name of that segment is T2. Okay. And the user is trying to save it in the table space by the name employees. Okay. So we know that as soon as in Oracle, if the user wants to create a new segment, at least one extent gets allocated to it, right? Isn't that the case, Azaz and Mahesh?
Yes, bro. Yes. Hello.
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 He has a connectivity issue. Hello.
Hello? Can you guys hear me? Like,
Yeah, bro, we can hear you.
okay, fine. I don't know why, but this Zoom app crashed. That's why I got disconnected. Okay, fine. Let me share my screen first. Okay, so we were saying that the basically this in this example, okay, the user wants to create a new table in the database, okay, or say a new segment by the name T2, and it is to be stored inside the table space employees, okay, and at least one extent will get allocated to that specific segment, right? And each of those extents are internally made up of something called as the Oracle blocks, right? We discussed about this yesterday, correct?
Yes, Dhruv.
Now, the thing is, all that modification, okay, all that modification has taken place, or all that new data has arrived in the database buffer cache. Okay, so coming to this diagram now. So if you see it here, all that new data, if you see these dirty buffers which have got either a modified image of the data, wherein when we say modified image of the data, that means the user has updated some or the other values. So that is called as a modified image of the data. Or else the user has fired few insert statements, that is the user wants to bring in new data into the database. Okay, so all of those data will be placed inside the dirty buffers in the database buffer cache. Now the thing is, all these dirty buffers or all the new image of the data or completely new data that is going to be put inside the database, that is present inside the buffer cache at this moment. Okay, but this database buffer cache in itself is a memory structure. It is present inside the RAM, right? This database buffer cache, if we go back to our architecture diagram, it is present where? It is present inside the instance, right? We will have to go back to the previous diagram, architecture diagram. Okay, so this database buffer cache in itself is present inside a memory structure. Okay, so this is not the permanent location of the data in the database. Okay, so from this memory structure, all that dirty buffers needs to be written to their actual location on the storage. Okay, so all those dirty buffers which are present inside the database buffer cache, okay, they will need to be copied to the permanent storage location of the data in the database, which actually is the data files. Okay, so these dirty buffers needs to be written to the data files. Now, who is going to do that? Who is responsible for writing these dirty buffers from the database buffer cache onto the data files? That is the
Checkpoint.
job. Sorry, who was that?
Ajas Python.
Yeah, what did you say, Azaz?
A checkpoint will do that one, I'm saying.
No. That is not the job of checkpoint. That is the job of this background process by the name DBWR, which stands for database writer. The job of the database writer process is to periodically read the dirty buffers from the database buffer cache, okay, and write them into the data files. Okay, so the DBWR process, that is the database writer, it will periodically get activated and it will read the dirty buffers from the database buffer cache and write them onto the data files. Now, these data files are the permanent storage for all that data into the database, right? We discussed it into the storage structure architecture. Here, that the database will have table spaces will have one or more data files in it. So eventually all the data is getting stored on the data files. Okay, and all these data files are basically occupying some or the other storage space, right? So that it is the job of the DBWR process to read the dirty buffers and write them onto the data files. Now, which are those events at which the DBWR background process or the database writer background process gets activated. Okay, I mentioned it here. When a server process cannot find a clean reusable buffer. Okay, so what does this point mean is, if say that one of the user fires a new command in the database, let's say an insert statement. Okay, an insert statement is fired by one of the users into the database, but for processing that insert statement, if there are no free, unused or clean buffers, if for processing that new SQL statement, if there are no unused buffers or clean buffers present inside the database buffer cache, okay, what Oracle will have to do is, it will have to apply either an LRU algorithm, or at the same time, what it will also do is, it will write the previously present dirty buffers from the data file, from the database buffer cache onto the data files. So if those 4 blocks, if the contents of these 4 blocks are written onto the data files, that means they will again be empty. They will, correct? These 4 buffers,
Unused
after
buffer.
that, exactly, after that, they can again be utilized for the new, for bringing in the result set of new queries, correct?
Yes.
Can you
Everyone?
repeat once? Dhruv, can you repeat once, sir?
Yeah, who was this? Azaz, right?
Yeah.
Yeah, okay, fine. So see, we are saying that if a user fires a new query in the database, this is that new query. It is an insert statement, or it's a, let's say, update statement, or let's say it's a create statement, create table statement. Okay. Okay. Now, to process these statements, internally, Oracle needs to find some free buffers inside the database buffer cache. Now, let's assume that there are no free buffers available inside the buffer cache, right? What Oracle has to do is, Oracle has to go and find, Oracle has to try and apply the LRU algorithm on the buffers that are present inside the database buffer cache at that point in time, right? So that it can make space for these new statements that are coming in, correct? Unless and until it applies that least recently used algorithm, how will it get the blocks for storing the data for the new statements? You understanding that, Azaz?
Yes, Dhruv.
Yeah. So it will try to apply that LRU algorithm. At the same time, what it will also do is, it will try to write these dirty buffers, okay, the previously present dirty buffers, into the data files. Okay, so that once these dirty buffers or the contents of these dirty buffers have been written to the data files, again those, after that, those dirty buffers will be available for use, right?
Yes.
Yeah, so that's what we are trying to say over here. When exactly this DBWR process gets activated? When a server process cannot find a clean or reusable buffer after scanning a threshold number of buffers. So if it doesn't find any free buffers available in the buffer cache, it will signal the DBWR process to write the dirty buffers onto the data files. Okay, or else perform some kind of purging as part of LRU algorithm. The other event at which this DBWR background process gets activated is something called as a checkpoint event. Okay, we'll discuss about the checkpoint event as well. Now, one more thing that you need to understand over here is we are representing the database writer process as DBWN. Okay, why is it being represented as DBWN is because Oracle allows you, or there is a possibility to configure multiple database writer processes in the database. Okay, so if we look at this diagram, you see here it is mentioned as DBWN, wherein that N is specifically mentioned because we can configure multiple database writer processes in the database. By default, there will be only one database writer process. Okay, but if at all you want, you can configure multiple database writer processes. Okay, now, which are the scenarios or what could be the possibility wherein there is a requirement to configure multiple database writer processes? Okay. So it might happen that your database is a highly transactional database. The users, they keep on inserting data into the database. They keep on updating and deleting data into the database. Okay. So in those scenarios, the single database writer process, it may not be fast enough. Okay. So in those scenarios, you might opt to configure multiple database writer processes. And that's why it is being represented as DBWN. Clear? If it is a single database writer process, you can represent it as DBWR as well. DBWR. Clear with that? Azaz, Deepak.
Yes, 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 yes.
Okay. So that's why that's the difference between say a DBWR or DBWN. DBWR, whenever you see DBWR, that means there is only one database writer process. DBWN is specifically used to mention that there is a possibility of configuring multiple database writer processes. What does it do? It will periodically read the dirty buffers from the buffer cache and write them onto the data files. And then what are those events at which that database writer process gets activated? First one is whenever a server process, it cannot find any free buffers. So it will have to either apply an LRU algorithm or else write all these dirty buffers onto the data files. Okay, plain and simple. The next event is a checkpoint event. We'll discuss checkpoint event in much more detail. Okay. Now, when we are talking about this database writer process, we also see something called as the database files. Okay, or say the data files in case of Oracle server. So when we are talking about data files, we again go back to the storage architecture or the storage server architecture in case of Oracle. How does the storage structure look in case of Oracle? This is how it looks, right? We said that there is going to be a database. A database can have multiple table spaces. Each of those table space will have one or more data files present in it. Okay. So at storage level, if you see, these are the data files wherein all your data will be present. You will be able, if you fire some or the other Linux commands like ls-lrt, you'll be able to list out all those files. Okay. So the database writer process writes all those data into the data files, and these data files are the location or say the final location of storing your data into the database. Clear with that? Do you understand what exactly is a data file now? What is the difference between buffer cache, database writer, and data files? Deepak,
Yes, Dhruv.
Azaz,
Dhruv, one doubt.
yeah, yeah, go on.
How will the DB writer will come to know that when it has to write the buffer into the
Yeah,
data file?
yeah. So that's what we discussed over here in this diagram. So first event is whenever the user tries to fire a new query, and for processing that new query, if there is no free buffer present inside the buffer cache. Okay, if there are no free buffers present inside the buffer cache, the DBWR will get activated and it will find out whatever are the dirty buffers present inside the buffer cache. It will write them onto the data files. So if it has written all these dirty buffers, let's say in this example, these 4 dirty buffers from the buffer cache to the data files, after that, these 4 buffers will be free. Correct?
Yeah, correct.
So that is the event. Okay. So if there is no free buffers present inside the buffer cache, how does Oracle make some space for bringing in new data inside the buffer cache? It has to write the dirty buffers into the data files. So at that event, that is the event at which the DBWR process will get triggered. This is mentioned here. When a server process cannot find a clean, reusable buffer after scanning a threshold number of buffers, then it signals the DBWR to write. You understand that now?
Yeah, Dhruv. And
As a
Dhruv, like, does the
yeah.
DBWR also writes data in from buffer to the data files when we commit something?
No, it doesn't get triggered at commit. The DBWR doesn't get triggered at commit. At commit, there is another background process that gets triggered and which is called as the LGWR, the log writer process. We will discuss that today. Okay. But the DBWR does not get triggered at commit. Okay. You go through the Oracle documentation. Nowhere you will find it mentioned that the DBWR gets triggered at the commit statement. Okay.
What about that whenever taking a backup
Yeah.
of the
Whenever taking the backup of what? Sorry.
data files or database, while taking backup, it will push the data to the data file.
No, at that time, there is no guarantee that this DBWR process will get triggered. Okay. Eventually, what happens is if you look at this second event, okay, that is at checkpoints. Now, this checkpoint gets triggered in the database after every 3 seconds. Okay. So after every 3 seconds, there will be something called as a checkpoint event that gets triggered in the database. Now that this is the, I'll just relate all that now. Okay. Now let me just go back to this architecture diagram. So after every 3 seconds, something called as a checkpoint background process gets activated. Okay. What is the job of this checkpoint background process? Okay. It writes something called as a checkpoint information into the control files. Now, these are, again, we haven't discussed about control files. We are yet to discuss that. So after every 3 seconds, the checkpoint background process gets activated and it will write the checkpoint information into the control files and the data file headers. So the checkpoint information gets written into the control files and the data file headers. Who signals that? The checkpoint background process. What it also does is, what the checkpoint process also does is, it will signal, it will make a signal to the DBWR background process to write the dirty buffers from the database buffer cache onto the data files. Okay. So Azaz or Mahesh, whoever mentioned that point, internally, if you are going to see in the database, if these background processes CKPT or DBWN, they will be continuously active. If the checkpoint background process is getting activated after every 3 seconds, and at every signal it if it keeps on spawning or if it keeps on sending a further signal to the DBWR background process after every 3 seconds, that means the DBWR process is almost active all the time in the database. Okay, so the event that you mentioned that, okay, when you start the backup of the database, right? That's what the event you mentioned. Azaz or who was that? Mahesh?
Yeah, okay, bro.
Yeah. So at that event also, it will of course write the dirty buffers from the buffer cache to the data files. Okay. Provided there is something to be written from the buffer cache to the data files. Getting it? So the primary triggering event for DBWR is these two events which I have mentioned over here. Okay, these are the primary triggering events for DBWR. Okay, at the same time, there are other internal triggering events as well in the database, which will signal or which will make a signal to the DBWR that it should write the dirty buffers from the buffer cache onto the data files. Okay, one of them could be the one that you have mentioned, that a backup has been triggered. Clear with that?
Yes, bro.
Yeah. Okay. So that is about the database buffer cache, the DBWR background process, and the data files. So data files is the final location of storing the data in your database. Okay. Now, the next thing that we wanted to see was LGWR background. We'll come to CKPT or the checkpoint background process again later on. But today we want to discuss the LGWR background process and how it is related with the redo log buffer. Okay. So can any one of you tell me what is the function or what is the purpose of redo log buffer in the database? What information does it store?
It's a transitional thing, transitional buffer.
Okay. Anyone else?
To recover the data, whatever you have, do the
Yeah, so exactly. So transactional or for a recovery purpose, it's one and the same thing. Okay. So yesterday we said that whenever the user fires a DML or a DDL statement in the database, something called as a redo entry gets generated. Okay. Something called as a redo entry gets generated whenever the user fires a DML or DDL statement. So we saw all these examples like insert, update, delete, and merge statements, or say a create statement. Okay, these four are DML statements, and if there is a DDL statement, DDL statements are create or else drop. Okay, so whenever any DML or DDL statement is fired in the database, a corresponding redo entry is generated in the redo log buffer. Okay. What is the purpose of that redo log buffer? We discussed that it is required for performing a recovery in the database. If for some reason there is a failure in the database, you will make use of a backup, a valid backup, and the redo entries to recover the database, all right, till the point of failure. Now, coming back to this example, okay, we'll take these examples again. Okay, okay. So if these are the DML statements that have been fired by one of the users, that means they have got a corresponding redo entry as well. and they are represented as say R1, R2, R3, and R4. Okay. So those redo entries are now present inside the redo log buffer. Okay. But again, the problem is this redo log buffer is present inside the memory structure, or it is present inside the RAM. It is not the permanent storage area, right? Your RAM can't be a permanent storage area, correct? So all that redo entry will need to be moved from the redo log buffer onto the permanent location or onto some of the physical files on the storage. So that's what is the job of this LGWR background process, which stands for log writer. Okay. So the job of log writer process is to copy the redo entries from the redo log buffer onto the redo log files. Okay. So what is the job of this LGWR or the log writer background process? It copies the redo entries from the redo log buffer onto the redo log files. Okay. That brings us to this specific diagram. Okay. So if you see it over here, I have represented this redo log buffer over here, and whoever is not speaking, please go on mute. Yeah, thanks. So in this
How
case, if
a
you,
redo log is generated?
who was that?
Deepak this side, bro.
So didn't we discuss that a redo entry gets generated whenever a user fires a DML or DDL statement? So I just now mentioned that whenever a user fires a DML statement, which is either an insert, update, delete, or merge statement, these are the DML statements, or the DDL statements like create or drop. Okay, these are example of drop statement. So whenever there is a DML or DDL statement fired in the database, a corresponding redo entry will get generated in the redo log buffer. Okay. So that redo entry, okay, that redo entry which is currently present in the redo log buffer, which is present inside the RAM on the server, that is the memory on the server, it needs to be written to the permanent storage file types. And those permanent storage file types wherein those redo entries will be preserved are called as the redo log files. Okay. You understand that now, Deepak?
Yeah, I understood that. But any DML entry fired into the database will create a redo
Not
log
any,
entry, right?
every.
Every.
Every
Okay.
DML and DDL statement that is fired by every user in the database, it will generate a redo entry. Okay. And those redo entries will be first placed inside the redo log buffer in the memory. And from there, it needs to be written down onto the permanent storage files, which are the redo log files. So who is going to copy those redo entries from the redo log buffer to the redo log files? It is a job of the log writer background process. Clear
So,
with that?
yeah, got it. So, Dhruv, like any DDL or DML entry that we fire will get copied. Like that same entry will be get copied to the redo log buffer, right? So, as if we press the slash or something, then it will get auto copied, right?
Exactly. If you are firing a slash enter, that means you are executing the same statement again. Correct? So if
So
the
that gets
statement,
copied from the redo log buffer, right?
see,
And is
if you
re-entered.
are, If you are pressing slash and enter, that means you are re-executing the previous statement in Oracle. Okay. So if the statement is getting executed and if that statement was a DML or a DDL statement, that means redo entry has to be generated. Okay. And that redo entry needs to be written to the redo log files.
Okay, Dhruv, understood that.
Azaz and Mahesh?
Yeah, okay, bro.
Yes, bro.
Any doubts about that? Yeah.
No.
Select. File is a very big topic.
Sorry. Who was that? Okay, fine. So, coming back to this diagram. So it is a job of the LGWR background process, which you see it over here. Okay, this is the LGWR background process. It will read the entries from the redo log buffer and it writes them onto the redo log files. Okay. Now, in this diagram, you see it how those redo log files work. Okay. So in case of Oracle database server, what we need to have is at any given point in time, in your Oracle database, you need to have two redo log groups. Okay. You need to have two redo log groups. Now, what are those redo log groups? Okay. So these redo log groups internally, they will be having the redo log files. This, which we saw it over here, that the LGWR is writing them onto the redo log files. These redo log files are basically present inside something called as redo log groups. Okay. And at any given point in time, your Oracle database requires at least two redo log groups. Okay. Now, each of those redo log groups can have at least one, and it can have more than one redo log files present in it. Okay. So if you see this diagram, there is this redo log group which have its name as redo log group 1, and it has got two redo log files. Okay. Similarly, there is another redo log group and that as well has got two redo log files in it. Okay. Now, what we can also have here is, say this redo log, second redo log group, it is having three redo log files in it. Okay. It is also possible. Okay. So one of these redo log groups has got two redo log files in it, and the other redo log group has got three redo log files in it. But why exactly has Oracle got this concept of two redo log groups? What are these two redo log files doing inside this group and three redo log files doing inside this group? Okay. Now, inside a group, if you see one member, at least, like I said, that there will be at least one redo log file or one redo member present inside this group. There can be more than one as well. So what is going to happen is when this LGWR gets triggered, okay, whenever this LGWR background process gets triggered, it will write the information or it will write the redo entries into the redo log files. That's what we discussed. Okay. Let's say that it is writing all that redo entries into this redo log file. Okay. Now it might happen that this redo log file that is named redo log file 1, it gets corrupted. It is possible, right? Azaz, Mahesh, Deepak.
Yes, maybe.
Yeah, Dhruv,
Yeah,
correct.
at OS level, it might happen that this file gets corrupted because of some XYZ reasons. Okay. So that's why what Oracle advises us to do is you do a multiplexing of these redo log files. what is the meaning or what is the use of multiplexing of these redo log files? This LGWR process, when it gets activated, okay, it will write those redo entries, or it will write whatever redo entries it is going to write inside the redo log file 1. It will write the same redo entries into redo log file 2 as well. Okay, so what we are achieving here is, if say for some reason one of your redo log file gets corrupted or deleted, you will still have those redo entries present in the other redo log file present inside the same group. Understand that?
Yes, Dhruv.
Azaz and Mahesh?
Yes.
But Dhruv, what about the second set where three edulog files are there?
Exactly. Yeah, we are coming to that. So whatever may be the number of redo log files present inside a group, okay, these are called as member, okay. So whatever may be the number of redo log members present inside a group, all of them are going to have the same information. Okay, so when the LGWR is writing the redo entries into this specific redo log file, it will write the same entries into this one and this third redo log file as well. Okay, so LGWR writes the same information into the redo log files of a group. Okay, whatever may be the number of members in that group. You understand that?
Yes, Dhruv.
Okay, so we are going to achieve nothing much if we are even going to configure, say, 2 or 3 more redo log file, or say the members inside this group. Okay, let me expand it. If you configure, say, another redo log file inside the same group, okay, uh, Oracle is going to write the same redo entries into these 4 files as well, into this 4th file as well. There is not going to be any difference over there. Okay, so you need to multiplex your redo log files because it contains very critical information, that is the redo entries. But having more than 1 or 2 copies, or having more than 2 multiplexed copies of the redo log files, it is really not required. Okay, for safety purpose, you might configure, say, 2 or at max 3 redo log files in a group, but more than 3 I have not personally seen for any client. Okay, so clear with this much, Azaz and Mahesh?
Yes, Dhruv.
Yes.
Mahesh,
Yes. Yes.
do
Yes.
you understand what we have discussed until now?
Yes. 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 No issues.
Okay. Yeah, so what LGWR does is, we mentioned that it will write those redo entries into the redo log files present inside the redo log group, and at any given point in time you need to have at least 2 redo log groups. Okay, why does it say that? Why does the Oracle documentation say that you should have, or you must have, at least 2 redo log groups? Because how internally it works is, say that it LGWR got activated, okay, and it starts writing all those redo entries present into the which were present in the buffer, redo log buffer, and it starts writing them onto this redo log files. Okay, and assume that the size of this redo log group, or the size of each redo log file present inside this group, is approximately, say, 500. Okay. Okay, so let's say that the size of these redo log files present inside inside this redo log group is 500 M. Okay, so what happens is when you are going to configure these redo log groups, you have to assign a size to it. Okay, you have to assign a size to it, the redo log files which are going to be present inside this redo log group. So let's assume that you have sized it to be 500 M. Okay, so what is going to happen when the LGWR gets activated and it starts writing those redo entries? At one point in time, this 500 MB will get full. Okay, at one point in time, that 500 MB will get full of all the redo entries that has been written on these files. Okay, so what does Oracle do after that? Okay, now let's say that the user fires another DML or DDL statement. Okay, if the user fires another DML or DDL statement, in that case, the LGWR will switch from this redo log group. It will switch from this redo log group and it will start writing on the redo log files of the next group. Okay, so as soon as the 500 MB which is present on the redo log file of this specific group is full, the LGWR will switch from redo log group 1 and it will switch to the next available redo log group. In this case, group 2. Okay, and then it will start writing the further redo entries on these redo log files. Clear with this much information?
When it fills a secondary reading group 2, what will happen?
Yeah. So once it has completely utilized all the space that is present inside redo log group 2, that's where this next background process comes into picture by the name archiver. We are representing that by the name ARCN. Okay, so what is the job of this archiver background process? The job of archiver background process is when the LGWR switched from group 1 to group 2. Okay, when LGWR switched from group 1 to group 2, it starts copying the entries from this group into something called as archive log files. Okay, it starts copying the data from this specific group into the archive log files. After some time, when this group also becomes full, that is all let's say that this redo log group 2 was also, it was of size say 600 MB. Okay, these groups can be of different size, there is no problem with that. Let's say that this group was of size 600 MB. Okay, so once this 600 MB is full, the LGWR needs to come back to this group. But if it comes back to group 1, the problem is there are redo entries. There are those redo entries which were initially written on this specific group. They are very critical for performing recovery in the database, right? LGWR can't straight away write all those redo entries or overwrite all those redo entries. Correct? Azaz? Mahesh?
Not good.
Sorry?
Sorry, I'm not getting what you said.
Yeah, okay. Okay, fine. So we said that the LGWR in the beginning, it will start writing the redo entries on this group. Once it gets full, it starts writing the redo entries on this group. Okay. But there will be some time when this group also becomes full. If this group was of size 600 M, there will be a time when that 600 MB will also get full. Correct?
Yes.
Yes.
Okay. Now, what does LGWR do in that case? you have got only these two redo log groups present in the database. So in that case, LGWR needs to come back to group 1. But the problem is, if it overwrites all those redo entries which were previously written on this redo log group, that means you will not be able to perform recovery in the database if those redo entries get overwritten over here. Okay. So before those redo
Yes.
entries get overwritten here in redo log group 1, there is this archiver background process. What its job is, it will copy all those redo entries from this group and it will write them into something called as the archive log files. So if all those redo entries have been copied from this group onto the archive log files, the LGWR after that can definitely overwrite those redo entries. You understand that now?
Yes, yes, clear.
If the entries, whatever entries or whatever the contents were present in these two files have been copied onto another set of files, that means these can now be overwritten, correct? So that's what happens. That's what happens, okay? LGWR makes use of these redo log groups in a cyclic manner. It will first start writing, or it will first start using this redo log group. Once this is full, it will start using this one. While it is writing, or while it is using this group, in the background, this background process gets triggered, or this background process gets activated. It will start copying those redo entries from this group and write them onto the archive log files. Meanwhile, when the LGWR completes writing the data to this redo log group, it will come back over here. When it comes back to this group, what the archiver process will do, it will start copying the entries from this group into the archive log files. And those archive log files are not going to be overwritten. Okay? Clear with this much information?
What size of archive log files, sir?
Sorry?
Size.
Size of what?
Archive log file size is then.
Yeah, so the size, so we don't provide any size of the archive log files, okay? Those archive log files are automatically going to be created by these archiver process. Okay, we don't size the archive log files. We are not much bothered about the size of those archive log files. But these will mostly be around, or say whatever is the size that you have specified for the redo log files. Okay.
I am asking what is the space of archive log files? Before we have
So
redo log group, we have 500 MB and redo log group have 600 MB, around 1 GB.
So it will keep on auto growing. Those archive log files, it will keep on growing. It will keep on creating new archive log files one after another.
Up to 2 DB.
There is no specific thing like up to, okay, over there, unless and until you have defined a parameter which goes like this. Recovery underscore file underscore test underscore size. Okay, so there is this parameter recovery file test size, okay, or it is db recovery file test size. Okay, so through that you give a specific value. Let's say you mention it as equals to 5 GB. Okay, so your archive log files are going to be present inside this recovery file test location. Okay, and you have given a maximum size of 5 GB to that location. So unless and until this 5 GB has been utilized, you are well and good. Okay. Once this 5 GB has totally been utilized, okay, after that your database will get hung. If you don't archive, or if you don't back up these archive log files, and if you don't clear up the space wherein these archive log files are getting generated, your database will hang. Are we clear with that, Azaz?
Yeah.
Okay. So what we do is, we as a DBA, we will definitely size this recovery file desk location wherein these archive log files are getting generated. We will do that. But at the same time, what we also have to ensure is these archive log files are getting backed up. These archive log files also has to be backed up somewhere. Okay, it will either be backed up on some of the cloud drive, or it will get backed up on your tape disks. Okay, or it will get backed up on some or the other file systems. So you have to ensure that from this 5 GB at any given point in time, at least 1 or 2 GB is always available for creating new archive log files. Okay, if your Oracle database is not, or if say this archiver process is not able to generate the archive log files, what it does, it will stop working. Okay, if it stops working, that means in your database you will not be able to process any queries. Okay, if there is no free space present to write redo entries in the redo log files, your database will stop functioning. It will just hang. Okay. Clear with that much information?
Yes.
Okay. So these are the various events at which, yeah, go on,
While
sorry.
copying this archive log files, from when it goes to redo log group, while copying this one is will copy and permanently copy and paste, cut that one, or how it will work?
Yeah, so it copies those redo entries from the redo log files into the archive log files. Next time the LGWR comes back to this group, it will
And
automatically
after
get
deleting this one,
overwritten.
after copying, it will automatically
Yeah, it will. The entries, the previous entries will automatically get overwritten. Was that the question?
I got it.
Oh, yeah. So LGWR, LGWR will know that, okay, this information has already been copied onto the archive log files, so it will start overwriting it. If it finds that these information has not been written to the archive log files, it will just wait. Your commands will hang. Okay, that's what we discussed now. So there are various events at which the LGWR process gets triggered. What are those events? A user fires the commit statement. The user fires the commit statement, right? To permanently save whatever changes he has made into the database, right? So as soon as the user fires a commit statement, the LGWR background process will get activated, and it will write these redo entries from the redo log group onto the redo log files. Okay, redo entries from redo log buffer to the redo log files. The next event is an online redo log switch occurs. Okay, so LGWR also gets activated when it switches from one group to the other group. Okay, so like we mentioned that once this 500 MB gets full, it has to move to the next group. That is called as a redo log switch. Okay, it also gets activated after every 3 seconds. Okay, then The next it says the redo log buffer is 1/3 full, or if it contains 1 MB of buffered data. So if 1/3 of 500 MB, which is approximately 160 MB or 165 MB, right? If the redo log buffer is 1/3 full, or even if it contains 1 MB of buffered data, the LGWR background process will get triggered. Clear with that? The next it says, before the DBWR writes the dirty buffers to the disk, the corresponding redo entries has to be written to the redo log files. Okay. Okay. Okay, let it be. Yeah, to the redo log files. Now we'll go back to this previous diagram. So, are you guys clear with these first 4 events? First 4, I'm only asking about the first one, not about the 5th one, the first 4 events. Any doubts about those first 4 events? Deepak, Azaz, Mahesh, any of you, any doubt about those 4
No.
events?
No, nothing, bro. But 3 second is a threshold time, or we can like default threshold time, or we can like alter it.
No, we cannot change that. That is the automatic event in the database. Like you cannot change the event or timing for checkpoints, which happens after every 3 seconds. Okay, you cannot change that. Similarly, you cannot change this event as well.
And is this like same for all the versions of Oracle databases? Is it?
Yeah, it is same for all the versions of Oracle databases.
Okay, sir. Thank you.
Okay, just give me a moment here. Yeah. So those are the first 4 events at which the LGWR gets triggered. The last event that you see here, it mentions that the LGWR will get triggered before the DBWR writes the dirty buffers to the disk. Okay. So coming back to this diagram, here we see the DBWR background process as well as the LGWR background process. Okay. So whenever the DBWR background process is going to get triggered, before that, the LGWR gets triggered as well. Okay. You understand that?
Parallelly, it will start both.
Sorry?
Parallelly, it will start both.
Not exactly parallelly. Not exactly parallelly. Before the DBWR is going to write those dirty buffers onto the data files. Okay. So those dirty buffers are generated in the buffer cache because of some or the other DML or DDL statement, right?
Yes.
Okay. So if they are generated due to a DML or DDL statement, that means for those DML and DDL statement, a corresponding redo entry must have generated in the redo log buffer, right?
Yeah.
Right? So before those dirty buffers gets written into the data files, their corresponding redo entries needs to be written to the redo log files first. So only after the corresponding redo entry has been written onto the redo log files, those dirty buffers can be written on the data files. You understand the relation between these two now, DBWR and LGWR?
So LGWR always acts ahead of DBWR, right?
Yes, we can say that. Yes, that's right. Mahesh and Azaz?
Yeah, got it.
Got it.
Yeah. So coming back to this example, if we are saying that this is a DML statement and it has generated a redo entries, so it has also generated some dirty buffers, right? So before these dirty buffers are written, let's represent these dirty buffers as something, let's say by this symbol, okay? And these redo entries by, let's say, this symbol, okay? So before the dirty buffers are written to the data files, what will happen is a signal will be passed on to the LGWR saying that these dirty buffers which were generated due to these so-called redo entries, and first these redo entries should be written to the redo log files. After that, these dirty buffers can be written down onto the redo log files. Sorry, onto the data files. Dirty buffers go onto the data files. So that's what is mentioned over here. The last event. Before the DBWR writes the dirty buffers to the disk, the corresponding redo entries has to be written to the redo log files. Clear with that? All three of you?
Yeah.
Yeah.
Yes.
And then we have also seen the use or functionality of the archiver background process. Because Oracle uses these redo log groups or redo log files in a cyclic manner, what needs to be done is before these redo entries get overwritten, they should be copied onto something called as the archive log files. Okay. So all those redo entries which are required for or which are important for performing recovery in the database, they will be copied into the archive log files. And you as a DBA, you have to ensure that these archive log files are preserved very, very carefully. If we lose these archive log files, okay, we will not be able to perform a recovery in the database. Clear with that?
Yes.
Okay.
Yeah.
So we have discussed this DBWR background process, LGWR background process, the archiver process, right? These three processes we have discussed today, okay? And the file types as well, database files, redo log files, and archive log files. Now, if you look at these background processes, these few of the ones have been highlighted as brown and few of them are highlighted as blue, okay? So the ones that you see in blue, they are optional background processes, okay? So the background processes, basically they are of two types. There are a few which are mandatory background processes, which I have represented them as brown in color, and there are a few which are optional background processes. Now, interestingly, the archiver background process is actually a optional background process. So what are those optional background processes? Optional background processes are those processes which are not mandatory to have in your Oracle database. So you can in fact afford, or you can run a database without the archiver process. Okay. So when I say that you are able to run a database, or you can run a database without the archiver process, that means will you be able to copy these redo entries from the redo log files onto the archive log files? If this archiver process itself is not present, how do we copy these redo entries from the redo log files into the archive log files? Will it be possible? Any
Maybe
guesses?
file backup can be taken.
Exactly. But it is not possible, right? You as a DBA, you don't have, I mean, you can't be just copying the files manually by yourself before every log switch.
By automation, we can regularly taking backups.
Yeah, so these are some of the things that you are thinking at this moment, but technically that is not how it happens. Okay, what will happen is, if you are not going to configure archiver process in the database because it is an optional process, what LGWR will do, once it has written, once it has completed from log group 1, it will switch to log group 2. Okay, then it will start utilizing this redo log group 2. Once this group 2 is also full, it will circle back to group 1 and it will overwrite all those redo entries. Okay, it will overwrite all those redo entries, and in that case you cannot perform a recovery in your database. That's why in industry you will see that your non-production environments like development or test or UAT, okay, all those lower environments, they are not configured in archive log mode because they don't have that much useful data. Okay, your non-prod environments, it doesn't have that much critical information in the database. Okay, so those data, in those databases, you can afford to run them in something called as no archive mode. Okay, no archive mode. So what is this no archive mode? In case of no archive mode, your LGWR background process will overwrite the redo entries. It will complete this group, it will move to this group, then it will come again back to this group, overwrite all those redo entries, come back to this group 2, overwrite these redo entries, come back to group 1, overwrite everything, so on and so forth. It will continue to do so. That kind of configuration is called as no archive mode. Okay, wherein the archiver process will not be present. It will not be copying the redo entries from the redo log files or from the redo log group to archive log files. Okay, the other configuration is something called as archive mode. Okay, or archive log mode. What happens in case once this group is full and LGWR starts writing to this group, parallelly the archiver background process will get activated. It will copy all those redo entries from this group into archive log files. Once this LGWR has utilized all the space present inside redo log group 2, it will come back to group 1. Okay, and it will start overwriting because these entries has already been copied. So when LGWR came back to group 1, this archiver process got activated and it will start copying all the entries from this group into the redo log files. That specific kind of configuration is called as archive log mode. So your production database, it will always be running in archive log mode, because all that data that is coming into your production database, it is very important, and you as a DBA, you have to be able to perform a recovery in the database. Okay, and the recovery is possible only if you have these archive log files. Understanding the difference between no archive mode and archive log mode?
Yes, Dhruv.
As Mahesh,
Yes, Dhruv.
any doubts about these two modes?
No.
Archive, anything that you can think of?
Yeah.
Okay. So your non-production environments, mostly you will be getting them in no archive mode because they are not that critical. And the clients, they don't want to spend that much of storage space for preserving these archive log files for non-prod environment. Okay. But for production environment, they have to ensure that they are copying all these redo entries so that in future, if something goes wrong in the production environment, they will be able to, you as a DBA, you will be required to perform a recovery. And you can perform a recovery only if you have a track of all those redo entries, right? Yesterday, we saw that example that, okay, you have a backup until 6 a.m. and there is a failure in the database at 9 a.m. So to be able to perform a recovery, you need a track of all the redo entries that were generated between 6 a.m. and 9 a.m. We talked about that example yesterday, right?
Yes. Yes, Dhruv.
So if you have not preserved those redo entries in the archive log files, you won't be able to perform a recovery. So that's why for production environments, it's important for the databases to be running in archive mode. Okay, but for non-prod environments, it's okay. I mean, even if there is some corruption in that database, the clients don't mind that, because you can always perform a database refresh, or you can always duplicate your production database to a non-production environment, right? So that is about uh, DBWR background process, LGWR, and your archiver background process. Clear with these three background processes? And
Yes.
the data files, redo log files, and archive log files. Okay, fine. So we'll stop for the day and then we'll continue again on Monday.
Okay.
Okay, fine.
Tomorrow
So
I
on
don't have
Monday,
class, no? Saturday, Sunday I don't have.
no, we won't have anything on Saturday and Sunday.
Yeah.
Okay. So what time do you want to start on Monday? 4:30 or 5?
4:30 fine for me.
I'm comfortable both the timings. I don't have an issue.
Okay, fine. Then let's start at 4:30. Is that fine with you, Deepak?
Yes, Dhruv, not an issue.
Okay, fine. Then let's connect again on Monday at
Dhruv,
4:30.
these videos will you update in YouTube, or are you going to share in
I
Drive?
think no. So I think we still have not covered the
Uploaded, not
entire
uploaded.
architecture.
Yesterday I have seen a first class which was updated in YouTube. The second and third classes have not yet updated.
Dhruv, we can stop the recording.
Think